This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to solve the equation cosine of x equals negative square root of 2 over 2. Now hopefully you recognize this, as one of the special angles has this, after simplifying it, negative root 2 over 2. If you don't recognize it, one thing you can do, which is opposite from what you're usually doing, is rationalize the numerator instead of the denominator. So watch what happens if I rationalize the numerator. That means I'd have to take the numerator multiplied by square root of 2 over 2. So in the numerator I get negative 2 over 2 square roots of 2. The 2's cancel, so I have a 1 in the numerator. So another way of writing this is negative 1 over root 2. Now that's completely optional, whether you want to keep it as negative root 2 over 2 or write it as negative 1 over square roots of 2. Some people like to look at it this other way because it's easier for them to recognize that as the special angle. And that's actually the 45-degree angle, basically. But we have to pay attention to the quadrant. We're trying to find x, cosine of x, that's negative 1 over square roots of 2. Where is the cosine negative? Well, that's over in quadrant 2 and 3. And let's see, that would be, this is how I do it. I think of that as negative 1, 1, and square roots of 2. That's going to give me a cosine of negative 1 over square roots of 2. But it's also negative, right, for this one. So that's two different angles for real numbers. This is broken up into 4, so remember this is 4 pi over 4, so that's 1, 2, 3 pi over 4. If you want, you could first think of these in terms of degrees and change to radians, which are real numbers. That's up to you. And let's see, so it's 3, 4, that would be 5 pi over 4. And those are the only numbers in between 0 and 2 pi, where the cosine is going to be negative 1 over square roots of 2. In quadrant 1 and 4, for instance, the cosine is positive. All right, now we need to find all real numbers that satisfy that equation. So the trick is, let's see, move this up a little bit so I have a little bit of space to show it. Move this also. Okay, here we go. So what can we do? As long as we get all of the angles coterminal, I like to think of it as angles even though we're discussing real numbers, we'll get everything. So we want all the values of x, so that x equals 3 pi over 4. Now how do I get all the coterminal ones? You add 2 pi k, or x equals 5 pi over 4 plus 2 pi k, where k is an integer. Now you can't consolidate these any further. If these were exactly pi units away from each other, like if I added pi to 3 pi over 4 and I got the next number, then I could consolidate, which I did in some other problems in previous videos. But in this case, that's not going to work. They're not going to, it's not going to work to add pi and get another thing, because if you add pi, you'd be over here, right? Totally different place. So here we have our solutions for the first and the second problem. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.